first
to the 99th percentile
P9.
All right. So a percentile simply is a value below which a given percentage of observations fall. Take note of that. A percentile is simply a value, right, below which a given percentage of observations fall. All right. So, for example, if you score in the 80th percentile on a test, it means you scored better than 80% of all the students who took that same test, right? If you score in the 80th percentile on a test, so what it means is that you have done better, all right? You've scored better than 80% of all the students who took that same test, all right? So most of the time, when we look at this part of data analysis, percentile, quartiles, deciles, we pay attention, right? When we have a figure, a particular percentile, decile, or quartile, right? The figures below are our points of observation, or let's say our reference point of observation. So you see that as we continue, you understand that better. So as you've read, for example, okay, I said that already. Percentiles range from first percentile, that's P1, to the 99th percentile, The reason it stops at 99 is because, like I said earlier, observations are mostly focused on the figures below, right? On the figures below. So if a student is on the 99th percentile, right, it means that that student has done better, okay, done better than 99% of the class, okay. And what that means is that you're scoring 100. If you've done better than 99% of the class, that means that you are that student who has scored 100. So percentiles are commonly applied in various real-world scenarios. So we use them in standardized test scores. They are also used in growth charts, all right, in healthcare and in other areas in the economy of the nation to measure the economic growth of the nation and all of that. So you see the application, all right, as we continue. So let's see how to calculate percentile. To calculate percentile. What did you say?
Can you go back to the other slide?
Okay, are you writing?
Yeah, I was writing, but let me take a screenshot.
All right, can take a screenshot. And for everyone, I want to say again that as the lesson goes on, all right, you put something down. Yeah, I'm going to send this to you after the class for you to go over it, right? But then there are some things that will come up during explanation that may not be in the note, and you need to take them down. So be wise. Now, next is how to calculate percentiles. So here we have example. Now, if you look at the figure on the right hand side, right? So you see that there we have, we just have numbers, clustered all together. That's an example of, data distribution. All right, an example of data distribution. So there are tools for analyzing data. All right, there are tools for data analysis such that you don't have to do it manually, right? The way we are doing it now. All right. For example, there is Excel. There is Excel, right, that can help to analyze data and some other tools like that. So for the sake of knowledge, we're going to see how to analyze this data by calculating percentiles. So we have an example here. Now let's walk through an example to see how percentiles are calculated. Imagine we have the following 10 student test scores, right? Already sorted from lowest to the highest. So this has already been sorted. So out of the 5 processes I gave you about statistics, okay, I mentioned 5. let's have 5 of you give me one each. I mentioned 5 processes of working on a data distribution. What are the 5 processes? Let a student give me one. Or 5 of you give me one each. Just raise your hand if you want to mention. Yes, Mimi Olua, Mimi Ola.
The collection of data.
Collection of data, okay. Let's have another student. That's correct. Collection of data is correct. Can we have, yes, Sibironke?
Analyzing of data.
And now analyzing data, analysis, isn't it? Isn't it? Are you there?
Arrangement data. Arranging data.
I didn't get that.
Arranging data.
Arranging data, okay. That's 3 already. David? David, are you there? David, can you hear me? Because I can't. I can't hear you. Maybe network. Can we have someone else? 3 has been mentioned already. 3 have been mentioned already. So can we have the remaining 2? Okay, let's have another student. Isn't it? I see you, but let's have someone else. Yes, those who have not spoken. Jesse, are you there? Jesse, can you hear me?
Yes, sir.
Okay, go ahead. We have 2 more.
Making sense of data?
I didn't get that.
I said making sense of data.
Making sense of data? How? How do you mean? Because I gave 5 processes, all right? In all, actually, you're making sense of data in everything. I saw Lyomi. Yes, go ahead.
Observation of data.
Did you see observation?
Yes, sir.
Oh, okay. Well, observation, yeah, observation is there, but then I gave 5. I started with all right, Bright, I've seen that. I started with first collection of data, rearrangement of data, all right, or arranging data. Third, excuse me, third is analysis of data. That's analyzing data. Fourth is what do I call fourth again? After analysis, interpretation, to interpret data. All right. After you've analyzed your data, then you interpret it in words. You put it in words. And after interpretation of data, number 5 is to present data. All right. So that's something to take note of. So I mentioned 5. I'm going to mention it again. The first one is to collect data, collection of data. The second is to rearrange data or rearrangement of data. The third is to analyze, analysis of data or data analysis. The fourth one is to interpret data. Interpret data, that's interpretation. Then the fifth is to present data. All right, the fifth is to present data. All right, good morning, Awal. Yeah, you are late, but then you have to join us from where we are. All right, so I hope everyone has gotten that down, just in case you see it later on. Okay, so how do we calculate percentiles? And for a while, we've not gone too far. Okay, I think we're just getting started, so just pay attention. How then do we calculate percentiles? Now, so here we have 10 scores, all right, and these 10 scores first they've been collected, all right, from a group of students or from a class, right? Second is that they have also been rearranged, all right, they have been rearranged. So we have from the lowest to the highest. 55 is the lowest, then the highest is 100. The highest is 100. So from 55 to 100. Now, the question is to find the 70th percentile. That's P70. To find the 70th percentile. So let's go step by step here. The first step is to calculate the position. All right. Now, the position of the 70th percentile. So we are saying that there are 10 test scores here. So to calculate, to find the 70th percentile, first we have to check the position. What is the position of the 70th percentile? The first thing to do, don't forget that the data, right, the scores have been arranged from the lowest to the highest, right? And the next thing to do is now to calculate the position, and that's very simple. To calculate position, all right, as you can see, the percentile in this case, which is 70 divided by 100. 70 divided by 100 times the number of data points. So here we have 10 data points, as you can see, 55, 1, 2, 3, 4. How many of you can see my pointer? You can see my pointer, raise your hand. Okay. All right, good. Okay, so from here, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So there are 10 test scores here, 10 test scores here. So to calculate the position of the 70th percentile, right, what we need to do is first calculate the position. So 70 over 100 times 10 scores. There are 10 scores there. So 70 over 100 will give 0.7, right? 0.7 times 10 will give 7. You can confirm that from your calculator. All right, confirm that from your calculator. 70 over 100 is 0.7. 0.7 times 10 is 7. All right, can you quickly confirm that? Let me give you 30 seconds. Confirm that and let me know if you have. Do that in 30 seconds. 30 seconds. Confirm. Okay.
Yes, sir.
Others, have you done that? Okay.
Yes, sir.
Yes, sir.
All right. That's good. That's good. So here the position is 7, number 7. So identify the value at that position. So don't forget, you have to arrange your values. You have to arrange your values from the lowest to the highest. So in this case, since the position is an integer, 7, we find the 70th, the 7th, sorry, we find the 7th score in the sorted data set. So let's check the 7th score from here. This is first position, the first score, the second, the third, the fourth, the fifth, the sixth, the 7th. So the 7th score, or the score with the 7th position, right, is 85. So the 7th score is 85. So what's the interpretation of this analysis? This means that 70%, which is the 70th percentile, 70% of the students, right, scored 85 or below. 85 or below. So that's what it means. Anytime you are asked to find the percentile, right, of a data set, right, or data distribution, first find the position of the percentile. Once you found the position of the percentile, right, then from the data set that has been arranged, right, accordingly from lowest to highest, then find that position, find the score with that position. So in this case, the score with the 7th position is 85. So that means that 70% of the students scored 85, right, or below on this test. All right. Is there any question on that? If you have any question, go ahead and ask now. If it is clear, can you raise your hand? Let me know if it is clear. If it is clear, raise your hand. If it is not clear, use the shared note and ask your questions. Keep your hands raised. Keep your hands raised. Let me see those who are not raising their hands. If you have a question, just go to the shared note and put your question there. I'm going to answer your question. Some of you are not raising your hands yet. We have a good number of you not raising your hands. If you have a question, just go to the shared note and type your question in there. All right, type your question in there. I'm going to answer your question. Bright, what do you mean by the first part? What do you mean by the first part?
The first side that you showed us before I left.
Okay, I've actually not explained. I've not really done anything. I just explained what percentiles are. All right, I just said percentile. That's what I explained how to calculate now. It's simply the value below which a given percentage of observations fall. Okay, below that that percentage. Okay, and let me also say that percentile means 100, like over 100. Okay, over 100. All right, so do we have any other question? Aldrich, Awal, Chidima, Chris, Syrian, David, you guys are not raising your hands. Emanuela, Franca, Francis, Princess. If you know you understand, raise your hand. All right, that's an instruction. If you don't understand, put your question on the shared notes. Those instructions are very important because not raising your hand, you give me the impression that you don't understand what I taught you. So David, this is the second slide. Is this what you're talking about? This is the second slide. Do you mean this slide? This one? Okay, so I'm just going to go over this again. All right. Everyone listen attentively. I'll just go over this again. To calculate percentile is simple. All right. I've explained before that percentile is simply the percentage. All right. It's a value below which a given percentage is a value below which a given percentage of observations fall. So now we have a question to calculate the 70th percentile. Calculate the 70th percentile, that's P70, of the data sets 55, 60, 65, 70, 75, 80, 95, 90, 95, 100. So let's say for example, right, these are 10 scores. Let's say these 10 scores are the scores, right, gotten from your class. Let's say from an exam, these are examination scores, right, of 10 students in your class in year 10. And I say that find the 70th percentile, right? Find the 70th percentile. Now, to find the 70th percentile, first calculate the position. Calculate the position, right, of the 70th percentile. So how do we calculate the position? It's simple. Now here, 70 over 100, don't forget percentile, like percentage, is over 100. So 70 over 100 times the number of data points. There are 10 scores there. So 70 over 100 is 0.7 times 10. 0.7 times 10 is 7. All right. So what this means is that the 70th percentile is on the 7th position. So as long as your data set has been arranged, right, just go there and look for the 7th position. So 55 is the first position. 60 is the second. 65 is the third. 70 is the fourth, right? Fifth, sixth, and seventh. So 85 is the 7th position. 85 is the 7th position. All right. So that said, what you need to do, right, now that you've identified the value at that position, okay, the 7th score is 85. The 7th score is 85. So the interpretation of that is that 70% of the students scored 85 or below. 70%, right? Because the 70th percentile is what? Is 85. So 70% of the class scored 85 and below. So if 70% of the class scored 85 and below, that means only 30% scored above 85. Above 85. So for the sake of what we're doing, like I said earlier, where our observation will fall mostly on this, on that score, what's it called, given percentage and below it, right? And below it. So let's move on. I want to believe that is clear. Now, so that's that about percentiles. Now the next is quartiles. Quartiles. So again, like we did the other time, just to make sure that everybody is following, I want you to turn on your mic on mute and then just read the first paragraph. First paragraph. Want to go?
Quartiles are special types of percentiles.
Quartiles are special types of percentiles that divide with sets into four equal parts. They are inherently established spread percentile, especially when looking at larger data sets.
That's it.
Okay. All right. So quartiles are special types of percentiles. Now, quartiles from quarter. So when you hear quarter, what will come to your mind is 1/4, right? Or a fourth part. Now, quartiles are special types of percentiles that divide the data set into four equal parts. Four equal parts. That's quartiles. They are incredibly useful for understanding the spread and center of your data, especially when looking at larger data sets. And then as we continue, we'll see how to calculate a median from quartiles. Now, let's see this. So Q1, which is the first quartile. Now, don't forget that the quartile is a type of percentile, and if percentile is over 100, right? Quartile is simply 1/4, right? Like a fourth part of 100. So the first quarter will be 25, right? The second quarter will be 50. The third will be 75. And of course, the overall is 100. So 25 is the first quartile. So here we have Q1. This is the 25th percentile. I need you all to pay attention. Quartile again simply means to divide the data set into four parts. It simply means four equal parts of a data set. Four equal parts of a data set. Now, so the Q1 is the 25th percentile, P25. Okay, the Q2 is P50, that's the 50th percentile. Now the Q3 is the 75th percentile. Okay, that's Q3, P75. Now, sometimes we have to calculate the interquartile range. That's Q3 minus Q1. Okay, and for you to be able to calculate interquartile range, you must have calculated Q1 and Q3. So let's see that. Next, you have to, can you zoom from your hand so that you can see this properly?
Sir, please, could you take it to your previous slide?
Okay, take a snapshot. Do that quickly. Are you done now?
Done, sir.
Okay. All right, so here, let's see how to calculate quartiles. So we have an example. We also have the data set. Now let's use the same student test scores we used earlier. It has already been sorted out: 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Yes, Joseph.
Sir, I'm really sorry for cutting you out, but can you take it back to the second slide?
Okay, you should have done that. Okay, do that quickly. Do that quickly. Are you done now?
Yes, I'm done.
All right, so everyone pay attention to this. So we have this data set. We have 10 data points. So let's find Q2, and let me say that Q2 is median. I think I didn't mention it in this slide. Look at this, the second quartile, that's P50, is also known as the median. So take note of that. That's the median. It divides the data into two equal halves. So the second quartile is the median. That's the middle number that divides the data set into two equal halves. So here we have 10 data points. There are 10 data points here. So since there are 10 scores, which is an even number, the median is the average of fifth and sixth scores. You know that already. We've done that before. That's see, because we have 10 scores here. If there were 11 scores altogether, what we would have done is to pick the middle number, right? And that's the median. But in this case, where we have even number of data points, what you need to do is pick the 2 points in the middle, right, and find their average. So in this case, 75 and 80 are the 2 points in the middle, right? Sum them together, divide by 2, you are going to get 77.5. So Q2 is 77.5. Take note of that. That's the median. Q2 is 77.5. Now, to find Q1, Q1 is the lower half median. Take note. The first step is to find the median. If you are asked to calculate the quartiles, the Q1, the Q2, the Q3, all right, and probably the interquartile range, the first thing to do is to calculate Q2. That's easier. That's an easier route, right? Calculate the median, which is Q2 of the data set. That's very simple. So in this case, the median is 77.5. Is Chioma in class? Chioma, are you there? Chioma, can you hear me?
Yes, sir.
Okay, I just wanted to be sure you're there. So the first is to calculate the median, right? Which in this case is 77.5. Again, how did we get to 77.5? Simply look for the 2 points in the middle. And the reason we are adding the 2 points in the middle, dividing by 2, is because there is an even number of data points. That is, there are 10 points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to find the middle point, right, that will be 75 and 80. These are the 2 points in the middle. Because if you divide this into 2, you are going to have 5 on this side, 5 on the other side too. So these two scores are the scores in the middle, 75 and 80. So we have two median numbers, not really two median numbers. So what we need to do there is to add them together and divide by 2. And that will give 77.5. That's our median. That's Q2. So now that we have Q2, we can now find Q1. That's the first quartile, which is also the lower half median. So now that we have 77.5, the lower half of the data, right? That's the scores before Q2. The scores before Q2 will now be 55, 60, 65, 70, 75. Don't forget, Q2 is 77.5. Let me annotate. This is Q2, 77.5, right? So the scores below 77.5, you come back here. The scores below 77.5, right? You have 55 to 75. Those are the scores below 77.5. So we have 55, 60, 65, 70, and 75. So the median of these numbers here, it's easy to find the median because there is an odd number of data points. So the median here is simply 65, right? That's the middle number. The middle number is 65. All right, that's the what's it called? That's Q1. That's the first quartile. So the first quartile, this is Q1, is 65. The second quartile, this is Q2, is 77.5. So to find Q3 will now be the other side, the upper half median. So what are the values above 77.5? There is 80. This other side, let me change the color. There is 80. All right. So you can see 80 to 100, 80, 85, 90, 95, 100. So the median, right, of this upper half is what? Is 90. Is 90. So Q3 is 90. Q3 is 90. Okay. Q2 is 77.5. 77.5. Q1 is 65 and Q3 is 90. So let's see the interpretation of this. Now this means 25% of the class scored 65 because that's Q1. Where's Q1 again? This is Q1, right? Q1 is the first quartile. And don't forget that out of 100, which is percentile, 100, right? Percentage or percentile. The quarter, you take the quarter of, if you divide that 100 into 4 equal parts, you are going to have 25 as the first quartile, you have 50 as the second quartile, you have 75 as the third quartile. So here, 25% of students scored 65. Okay, 25% of students scored 65 and below, all right, or below 65. 50% scored below 77.5, okay, which is the median. Then 75% scored below 90. So the middle 50% of scores fall between 65 and 90. Okay, that's the interpretation. The interpretation again, Q1, which is the first quartile, which is 25% of 100. Okay, that's P25. So we have P25, we have P50, right? We have P75. So the first quartile, which is Q1, which is the 25th percentile, is 65. And what that means is that 25% of the class scored 65 and below. Q2 means that 50% of the class scored 77.5 and below, right? Below 77.5, right? Why 75% of the class, right, scored below 90. All right. If you got that explanation, raise your hand. If you have any question you want to ask, put it on the shared notes. Let's do that quickly. If you know you understand what I just explained, raise your hand. If you have any question, put it on the shared notes. You are not allowed to stay in between. Okay, you are not allowed to stay in between. So explain, just put your question there. What exactly is the problem? Is it Q1? Is it Q2? Is it Q3? If you understand, raise your hand. Okay? If you understand, raise your hand. If you have a question, be precise about your question. Don't just say as you repeat. Okay, tell me what exactly you didn't get. What did you miss? Okay, so that's Jesse, I think. So the lower half of the median is 25%. Yes, it's 25%. The first thing is to calculate median because that's an easier route, all right, to calculating other quartiles. So once you have Q2, the lower half, right, the lower half or the lower half median of the data set, is the Q is 25%, and that's Q1. Jesse, I hope you got that. Okay, David says, I don't understand this step 3 to 4. Okay, if you understand step 1, okay, which is the median, that's simple. First, calculate the median of the data set. All right, once you have calculated median, you see that number 77.5, which is the median in this case. You know how to do that. Now, that number has divided the data set, because median simply means middle number. So that number has divided the data set into two halves, right? So the lower half median is the Q1, which is 25 percentile. Okay, that's the 25 percentile. So if the data set, you can see where I used black and red ink. All right, you can see that. So the lower half is from 55 to 75. That's the lower half. The median there, that's the middle number of that lower half, which is 65, is Q1. Is a first quartile, is Q1. The median of the upper half, which in this case is 90. You can see the red ink I used there, which in this case is 90. That median is Q3. Is Q3, right? That's 75% percentile, all right, or the 75th percentile, rather, 75th percentile. Okay, so the Q1 is the 25th percentile, which is the median of the lower half. All right, so the first thing you should do when you have a data set is to find the median. First, find the median. All right, I can't overemphasize that. First, find the median. All right, and with what I've done now, Bright, I've just explained again. All right, first find the median. Once you have the median of the data set, which is Q2, so by looking for the median, you already have Q2. Okay, so what you are left to do is to calculate Q1 and Q3. So once you have Q2, which is the median, that Q2 has divided the data set into two. So the lower half, which in this case from 55 to 75, the middle number is 65, right? The middle number is 65. That's Q1, or the 25th percentile. Q1 is 25th, Q2 is 50th, Q3 is 75, 75th percentile. Okay, then Q3, to calculate Q3, is simply the median of the upper half, which is 90 in this case. So the interpretation is that 25% of students scored below 65, right? 50% scored below 77.5, and 75% scored below 90. All right, so let's look at deciles or deciles. So deciles, like from 10, okay? So just get it, percentile, 100. Yes, Liomi.
Sorry, sir, please can you take it to the previous slide?
Okay, I thought you'd have taken a snapshot of that. Can you do that quickly?
Done, sir.
All right. Okay, so deciles are another way to divide a data set, but instead of 4 parts like quartiles, okay, they divide the data into 10 equal parts. Instead of 4 equal parts as in quartiles, right? These ones divide them into 10 equal parts. So each decile represents 10% of the data because it's divided into 10 equal parts. Okay, so just like quartiles, deciles are closely related to percentiles. So we have like percentiles as the reference point. Okay, Bironke, you want to say something? Okay. So here, the first decile, right, which is D1, is the 10th percentile. So don't forget, deciles divide, or what they mean is that the data set into 10 equal halves. So if you have, let me ask this question. If you have 100 data points, let's say there are 100 data points, and you want to divide them into 10 equal parts, into deciles, right? Now, who can tell me how many points will you have in each decile? How many data points will you have in each decile? If you have 100 data points, yes, Jesse?
Would we have 10?
10, correct. All right, that's correct. So if out of 100 data points, you want to divide the data points into deciles, right? That's the first decile, the second, you are going to have 10 deciles in all, right? You are going to have 10 deciles in all. Then in each decile, you are going to have 10 data points. So 10 times 10 is 100 data points. So here, the first decile is the 10th percentile. The first decile is the 10th percentile. The fifth decile, which is D5, is the 50th percentile, which is P50. You see how they are related, right? So in this case, P50, don't forget, P50 is the median and also the second quartile. You see how they are related. The fifth decile is the same as the 50th percentile, P50, which is also the second quartile and the median of the data set. All right, I'll take that again. The first decile, D1, the first decile is the 10th percentile. All right, I just give an example of 100 data points, right? If you divide 100 data points into 10 equal parts, you are going to have 10 in each decile, right? You are going to have 10 like that, okay, in each decile. So the first decile, right, will be the 10th percentile. Now the second, like that, the 20th percentile, the third, the 30th, the fourth, the 40th, the fifth, the decile will be the 50th percentile. The fifth decile will be the 50th percentile. Don't forget, 100 data points in all. So if the first decile is 10, the second one too is 10, the third is 10, that's 30 already. The fourth is 10, that's 40. The fifth also is 10, that's 50. So that's where you are going to find the 50th percentile, but that is the fifth decile. So that 50th percentile is the second quartile. We just saw that not quite long, and that is the median. So the 9th decile is the 90th percentile, which is P90. So deciles are particularly useful for categorizing data into 10 distinct groups, making it easier to identify specific segments within a large data set. Okay, so common applications, we use them for income distribution. Okay, economists often use deciles to analyze how income is distributed across a population, showing what percentage of people fall into different income brackets, like how much they earn, or maybe monthly or annually. You can use deciles to group people. Then we also use it for risk assessment in finance or healthcare. All right, to create risk assessment bands, grouping individuals into categories based on their risk factor. So let us see how to calculate deciles. So we have an example here, and I want you to pay attention closely. I don't want to hear, "Sir, come again," all right, or "Sir, explain everything again." I don't want to hear that. So pay attention closely. Don't be distracted. Pay attention. So to calculate decile, now here we still have our, what's it called, our data points, 10 data points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the fourth decile, now this is already 10. Do you understand? This is already 10. So what that means is that if deciles will mean to group them into 10 equal parts or into 10 parts. So we already have 10 here. Okay, we have 10 here already. So we are to find the fourth decile and the eighth decile. The fourth decile and the eighth decile. Now, step 1, convert the decile to its corresponding percentile. D4 is equivalent to 40th percentile. I've explained that before. D4, all right, is the same as the 40th percentile. Okay, then D8 is 80th percentile. So let's calculate the position like we did as at the first time. So 40th percentile, that's 40 over 100. Okay, times 10, that's the fourth position. So the fourth position here is 70. 1, 2, 3, 4. That's 70. Here, the position for D8, okay, 80 over 100. 80 over 100 is 0.8 times 10. That's 8. The 8 score is 90. 1, 2, 3, 4, 5, 6, 7, 8. This is it. A simpler way to understand that is that since there are only 10 data points here. Yes, Layomi.
Why do D4 end with 40? Is it because of the 10?
Okay. Hold on. I'll respond now. Now, I explained already from here, okay? Look at what we have here, that the first decile is the 10th percentile. The first decile. Decile is to group or arrange the data set into 10 equal parts. So into 10 equal parts, so we have deciles, okay? We have, what's it called? We have, let's say we have 10 deciles. So the first decile, which is D1, is the 10th percentile. So look at this. Here we have 10 scores. So normally, ordinarily, to group this into 10, this will be D1, this will be D2, this is D3, this is D4, D5, D6, D7, D8, D9, D10, right? I mean, in a simpler way, there are 10 data points here. So this is D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. Okay, and that's simple because we only have 10 here. You understand? We only have 10 here. So a simple way is to find D4. D4 is already 70 because we only have 10 scores here. D4 is 70, right? D8 is 90. Even without using all of this, without explaining it this way, because we have 10 scores already here, all right? And if you're getting these sides, you must have the data set arranged in 10. So we already have 10 here. So that means that this is D1, this is D2, this is D3, this is D4, this is D5, this is D7, D8, D9, D10. Now let me ask this. What if we have 20 data points? I want somebody to answer this. If we have 20 data points, now how many data points are we going to have in each decile? Who can answer that? If we have 20 data points, let's say we have 20 here, how many data points are we going to have in each decile? Who wants to answer that? How many? Anyone? If you know the answer, just ask. Some of you know the answer, but to speak is the problem now. If there are 20 data points, right, and normally for decile, you are supposed to group them into 10, and you have 20. So how can you group 20 data points into 10 groups? How many data points will be in a group? How many? Nobody? Yes, Joseph, right. Okay, David said 2. He wrote 2.
I'm thinking that you will divide it 10-10.
If no, you are not. You don't understand. All the 20 data points should be in 10 groups. All the 20 data points should be in 10 groups. Lie on me. Yes, lie on me. I'm waiting. 2. Very correct. David also typed 2. So if you have 20 data points and you have to group everything all into 10 groups, and you have 20, like saying you have 20 students, all right, group them into 10 groups. Let's have 10 groups in the class. That means you are going to have 2 students in each group. Yes, it's 2. You are going to have 2 students in each group. So that group is what we call decile. is a decile. All right. So in this case, we have only 10 data points. So that means that we can as well say that they are already grouped in 10, right? So each score here will be a decile. So 55 is the first decile. 52 is this, 60 is the second. Sorry, it's raining here. All right. Hold on, please. All right, if you can still hear me. So 55 is the first decile, 60 is the second, 65 is the third, right? 70 is the fourth, 75 is the fifth, right? So the question now says find the fourth decile. So who can tell me what is the fourth decile, even without calculating anything? From what I just explained, what's the fourth decile?
70.
Yes? 70. Is that correct?
70. Yes, sir, it is.
Yes, it's 70. 70 is the fourth decile. The eighth decile is 90. Right? So that's correct. So, but we can have a case where we have maybe less than 10 or even more than 10. So note that D4 is the same thing as P40. That's the fourth decile is the same thing as the 40th percentile. The eighth decile is the same thing as the 80th percentile. So the way we calculated percentile are the first. So to calculate P40 divided by 100, right, times 10, that's the fourth position. The fourth position is what? Is 70. So this is D4. D8, 80 over 100, right, times 10, that's 8. So the 8 score is what? Is 90. So this means that 40% of the students scored 70 or below. 40%, while 80% scored 90 or below on this test. Any question? Any question? I think we are done here already.
No
If you
questions.
have any
Sir.
question, you should ask me.
No.
Okay. Let me know if you understand. Can you use the shared note and just type it there? I understand, sir. Type it there. Do that in 1 minute. Okay. All right, so I'm going to give you task now. Now, don't forget what I said about interquartile range. Let me go back there. Interquartile range is simply Q3 minus Q1. So just in case you see it, this is, where is that? This is interquartile range, Q3 minus Q1. You can see that. So once you have Q3, all right, and don't forget, if you want to calculate quartiles, the first thing you calculate is the median. So once you calculate the median, which is Q2, then the lower half get the median 2, that's Q1. The upper half get the median 2, that's Q3. So the interquartile range is simply Q3 minus Q1. That's that about that. So let me look for a question for you. I want to give you a question that will trouble you small, just small. It will trouble you. One question. I hope you allow me to do that. It will trouble you only small, just small. It won't even trouble you as much. All right. Okay, let me type it here.